Unit 11, Intelligence. The first thing we need to know about intelligence is the definition. And so for the definition of intelligence, there are three parts. It's the ability to learn from experience, to solve problems, and to use knowledge to adapt to new situations. These three questions are what we will be able to answer at the end of the PowerPoint. Is intelligence testing society's best means of identifying those who would benefit from special opportunities? Is intelligence testing discriminating? How did intelligence testing come about? And we'll talk about some more things. So when we talk about intelligence, we most often use the term IQ. And IQ is an acronym. It means intelligence quotient, so it's a measure of your intelligence. Well, one of the problems we experience is a reasoning error called reification, because when we talk about someone's IQ, we attribute that as a thing. It's some attribute of their personality. It makes them who they are, and that's too much. We're giving too much credit to IQ, because really, IQ is a score on a test. It is not part of a person. It's not a thing. So we can't say that it is. But because a lot of people do have that association, we call that reification. Are those who are intelligent rich? Here is a chart to measure income, but also to look at IQ score. And so we don't see a huge relationship here, but if you start to notice, there is the slight upward trend, because we do see that as intelligence scores get higher, people are also making more money. And that's how we see that slight change. The correlation coefficient here, that's going to be a 0.3. And it's going to be positive 3. So we do know that there's a slight positive relationship. But you will see that people who have an IQ of 130, which is very, very bright, because the average IQ is 100. So these people who are scoring 130, they're still making under $30,000 a year. So being smart and rich, yes, there's a slight relationship, but it's not significant. When we talked about personality, we talked about the trait theory. And with the trait theory, we talked about Gordon-Allport, and he is lumping traits together. This is kind of what we're talking about with intelligence. So we've got some different people who believe in these different types of intelligences, and I'm just going to tell you their theories. The first is Charles Spearman, and he's the one that actually came up with the term factor analysis. He developed this whole idea of how we can statistically measure things. So with factor analysis, basically what we're doing is we're clustering like items. So for example, in personality, when we talked about factor analysis, we used the example of an extrovert. We didn't look at those who are sociable, talkative, outgoing in different ways. We lumped those all together and we called it an extrovert. Charles Spearman is doing the same thing. He's lumping traits together. So he says that if someone does well in verbal skills, they're actually likely to do better on all the other tests. He calls this general intelligence. So he is really basically clumping everything together, and we call it the G factor. So the G is just for general. I know that's not very very creative on his part, but Charles Spearman comes up with the G factor and just says that people have a general intelligence. L.L. Thurstone, he has these 7 different intelligences, basically, or mental abilities, but what he finds is that they do tend to cluster. L.L. Thurstone doesn't think that we should give someone just a G factor and label it general intelligence. He does think that we still need to divide it out. But what he has found through his studies is that if someone does well in one intelligence area, like maybe they do well in verbal skills, then they're also likely to do well in math skills and science skills. But he is reluctant to say that a person has a G factor. So I want to talk briefly about savant syndrome. Savant syndrome is where someone excels in a certain area of intelligence but may be lacking severely in other areas of intelligences. People might be able to draw or make figurines, or they've got fantastic memories. If you've ever seen Rain Man, That is a great example of savant syndrome. Rain Man had to live in an assisted living place because he could not live on his own. He was asked at one point how much a candy bar cost, and he said $150. And the doctor said, well, how much does a car cost? And he said, about $150. He had no sense of reality, but he could read a phone book, and he memorized everything that he had ever read. This is an example of savant syndrome, and his ability is to draw. So I'm going to go ahead and play this video for you so you can see what it's all about.
His nickname is the Living Camera. Stephen is autistic. He lives in a world of his own. Communication is difficult for him. He didn't speak his first words, pencil and paper, until he was 5. Yet when he was 11, he drew a perfect aerial view of London, after only one helicopter ride. Even the number of windows in all the major buildings in his drawing was correct. For this film, we're testing the living camera in Rome. Stephen has never seen the Eternal City from above before. After only a 45-minute helicopter flight, we'll ask him to draw a 5.5-yard panoramic picture of the historic city setting, without having a second glance at it. Stephen has 3 days. In these 3 days, Stephen will have to keep thousands of details in his head. The innumerable cupolas, the tiny winding streets, all the balconies and windows of the endless array of houses, and each and every column and window arch of Rome's major sites, from the Pantheon to St. Peter's to the Colosseum. Five and a half yards of paper can look scarily empty. The amazing thing, Stephen starts the drawing as we would, with the Church of St. Peter's. But he doesn't do any sketches, nor roughing out of the space for the drawing. It's as if the panorama already existed within his head, with all the proportions, all the roads, all the details. At the end of the second day, Stephen is a good halfway through his creation. After 3 days of his drawing marathon, even Stephen Wiltsh starts to tire. He has filled in more than 5 yards of paper in fine pencil. He has been restlessly aligning window to window and house to house, because Stephen loves to be applauded for his art. In the left corner, he's finally reached the ruins of the Forum Romanum. Stephen's sister Annette is rejoicing with him. He's made it. Obviously, he's pleased with his work. Yet our vexing question still remains. How precise was Stephen's ability to memorize? Is it really true that you could only see a single curve of the Tiber from above? We started to compare the accuracy of the drawing with the real thing. Is Stephen's version of St. Peter's cupola too dominant? Yet here again, like with the curve of the Tiber, Stephen is frighteningly right. We wondered if the famous Roman hill should probably stand out more in Stephen's panorama. But again, Stephen had seen it better. From 1,000 feet up, the hills are, optically, almost level. Checking the Pantheon, we did discover some minor inaccuracies on the roof. But the number of columns at the portal is, again, absolutely correct. And, despite our doubts, Stephen has drawn one of the most complex buildings, the Colosseum, so precisely, it's practically a blueprint of reality. mysteries. Had he had more time with sister and Edmund, he would have put in even more detail.
Some of them areas all the hard. Lots of detail, things some of the cities and the neighborhoods and the villages. And the easy part is St. Peter's and Forum and Colosseum, and memorize it by head and by memory.
Pretty amazing, right? It is just incredible how someone can be so highly intelligent in one area. So it was interesting to see that he didn't start speaking until the age of 5, which we know from language development. Language, you're in the one-word stage at age of 1, and then by age 2, you're in the two-word stage, and then a little bit after that, you're in telegraphic speech, where you're going to use a verb and a noun, and brings you closer to formal language, where you're developing complete sentences. So, that's looking at one form of intelligence and taking it to the extreme. Howard Gardner talks about multiple intelligences, and he discusses 8 different multiple intelligences. Linguistic, logical, musical, spatial, kinesthetic, interpersonal, and naturalist. Naturalist is the newest. So Gardner is always thinking about intelligences and what he should add and what he should change in his theory. So it isn't really important that you know who has which type of intelligence. These people over here really are not all that important, but you do need to know what each type of intelligence means. So if you are linguistic, you are about language and you've got very good verbal skills. If you're logical or mathematical, chances are you're going to do very well in a math class. But you're also logical, so you like patterns and organization and solving problems. That would interest you. If you're musical, you might play an instrument, you might sing, you might be able to read music. Anything along those lines are musical intelligence. Spatial, that's looking at spatial organization. So if you like reading maps or atlases, that is something that would really pique your interest. Knowing how much space, like in Stephen's drawing, he knew how much space to leave between one house to the next and one street to the next to make it all work, but just being able to spatially organize. Bodily kinesthetic, that's usually athletes tend to fall in that area. You know your body well. It's also part of that hands-on learning. You've got to touch something. You've got to be tactile to learn. And then you've got intrapersonal and interpersonal. These are different, so I want to make sure that we understand the difference here. If it's intrapersonal, it's about the self. You understand yourself, your feelings, your thinking, but you have a good understanding of you. You've got a good self-concept. If it's interpersonal, then you have a good understanding of other people. You can read other people, you can communicate well with others, but it's with other people. In this naturalist intelligence, you have a good understanding of the environment. Maybe you love to be outdoors. Maybe you know trees and plants and different things along those lines. If you want to find out what kind of intelligence you have, you can take this quiz down here. You'll have to type in that website, but that's just one free one that I found online. Or I've got an Excel worksheet. And this was not working on the iPad, but if you were opening this on a laptop computer, I have this document in your Edmodo folder under Unit 11, so just know that's there. One thing that's really interesting is the concept of emotional intelligence. Now, most people do think that you do have a form of emotional intelligence, and that would be, perceiving emotions, revealing emotions, different things along those lines. But it's interesting because when Howard Gardner was asked about emotional intelligence, he said, nope, that's too far. People don't have an emotional intelligence, which is kind of funny because he came up with 8 different intelligences, but says that emotional intelligence isn't one. But if you think about it, emotional intelligence does kind of fit in with intrapersonal and interpersonal intelligences, so maybe he felt that he had already included it somehow. but when he was asked about it, he said no. Robert Sternberg has 3 types of intelligences that he studies, not the 8 that Howard Gardner has. But Robert Sternberg has analytical, creative, and practical intelligences. With analytical, we're looking at school smarts. A lot of people, when they think about intelligence, it's all about testing and how well you do in school. That's that analytical part. Some people think that if you excel in school smarts, you might be lacking in street smarts, which is what the practical intelligence would be, kind of your street smarts. So we've got school smarts, street smarts, and then in the middle is creative. So creative intelligence is your ability to react to novel situations. That's your ability to react to new situations. Are you going to be able to accommodate things? Are you going to be able to find solutions in everyday objects? For example, if you needed to hold the hood of a car up and the little metal arm thing wasn't in the car, maybe it was broken, how do you hold the hood up without someone standing there holding it up? Well, maybe there's a traffic cone nearby, so you could put the traffic cone in and that would hold the hood up. So just your ability to react to those different situations. Just to develop creative intelligence a little bit more, MacGyver was a TV show a long time ago, and MacGyver was always stuck in these awful situations, and he had to find his way out, and he could set off a bomb with bubblegum and a paperclip if he had to, but he always had random items, but he could use those random items to get himself out of any situation. So if you ever hear someone say, "Oh, good job, MacGyver," that's what they mean, that you've got really good creative intelligence, that you used some odd object to figure something out. So, ever been in the bathroom and this is what you see, an empty toilet paper roll? Well, what do? What would MacGyver do? So this is moving on from Sternberg. This is not part of Sternberg's 3 intelligences. This is different. So this is just emotional intelligence, and we consider it an aspect of social intelligence. It's the ability to perceive, understand, express, and manage emotions. And people that have high emotional intelligences do tend to be a little bit better at relationships because they have an understanding of what people are feeling and they find ways to communicate and work through those emotions with other people. Could you tell if someone were intelligent just by looking at their brain? Actually, we do find several correlations here. So we find that as your brain size increases, your intelligence tends to be higher. Also, the number of synapses are positively correlated to IQ. Higher intelligence scores, people tend to have more gray matter. So in your brain you've got gray matter and you've got white matter. The white matter are axons and dendrites, and the gray matter is the cell body. That's soma, that's keeping the cell alive. So if you've got more gray matter, you have more cell bodies, and so we do see that that's linked to higher intelligence. The first intelligence test started back in France, and this was with Alfred Binet. So at this time in France, they decided that all kids needed to go to school, and they wanted to know how to place them. So the first intelligence test was really a test for placing kids in the right level of school. Louis Terman was a professor at Stanford. He took the Binet test and brought it to the United States, basically. But he made some modifications, he changed it up a little bit, and so we call that test the Stanford Binet test, which is really just a modified Binet test. William Stern is the person that said, we need to come up with this number, we need to come up with an IQ, we've got to figure out how to compute an IQ. Let's look at this example. If you take this test and you get your mental age, and your mental age is 8. So 8's at the top. Then you look at how old you actually are. Maybe you are actually 7. So you're 7 years old, but when you take this test, you get the mental age of 8. Well, then you take 8 divided by 7, multiply it by 100, and then your IQ is going to be 114. Here's your second example. You're actually 12 years old, but you take this test, and the test computes that your mental age is 9. So I take 9 divided by 12, and I multiply that by 100, and that gives me an IQ of 75. So if you remember from a previous slide, we said that the average IQ was 100. So if you're 12 and you're testing like a 9-year-old would, then you are below average in your IQ. The tests that we use to assess intelligence are aptitude and achievement tests. Aptitude tests are tests measuring your capacity to learn. So an aptitude test is going to test how well you will do in the future. An achievement test is a test measuring what you have already learned. So this is your past or prior knowledge. Well, there we go. Current tests that we use are the Wechsler Adult Intelligence Scale, and there's a Wechsler Intelligence Scale for children. If you think about the IQ equation, that works well for kids, but it's really hard to make a difference between being 45 and 46, or 57 and 58. So we do have different scales for adults than we do children. Another thing that is important about IQ tests is that they are standardized, reliable, and valid, and we'll discuss that in future slides. This is an example of the Wechsler Adult Intelligence Scale. You can see there's verbal, there's performance, there's arranging, object assembly, so there's a variety of methods that your intelligence is tested. Standardization is one of the first pieces of good test construction. There's something called a standardization sample, meaning that we're going to kind of test out ahead of time, so that the AP exam that you will take on May 2nd at noon, that test is given to a group of college students who are in a Psych 101 class. And so we compare the results of that standardization sample of that college course to the actual high school students' data. A test is reliable if you are getting consistent results. So like, for example, the Myers-Briggs test. If you took that over and over and over again, you would always get the exact same thing. It's not just by the person though, it's by looking at all of the scores collected. So like the ACT. Usually, freshmen will have a certain ACT score on average, and we see that same thing from year to year. That's proving that that's a reliable test. If you think about a target, okay, here's my target. If I am a reliable shooter, maybe I'm an archer, and if I'm a reliable shooter, I'm going to get consistent results every time. So even if I keep hitting in this spot, I know it's not the bullseye, but if I keep hitting that same spot, I'm reliable. I'm consistently getting the same results. These two terms here, these are not in your book, but you do need to know these. There's something called split half reliability. This is where you take the test and you divide it into equal halves, and you see if the scores are the same. So for example, if you have 50 multiple choice questions for me, and I take the first 25 and the last 25, you'd probably have the same score. A test or retest is using the same test on 2 occasions, and this is kind of what we talked about with that Myers-Briggs. You take it at 2 different times, but you're still getting the same results. The validity measures the accuracy of the results. So if I go back to being an archer, and if I've got my target over here, accuracy is actually getting the bullseye on this one. When I look at a test, I have to test what it is that I intend on testing. So if I'm giving you a test in psychology, I'm probably not going to ask you questions in French. Likewise, if you're taking a test in a French class, you're probably not going to be asked questions on psychology. That would not be valid. There are 2 forms of validity. You've got content or criterion validity and predictive validity. Predictive validity is looking at how well you will do in the future. It's predicting a behavior. When you go and you take your permit test, that test is to predict if you're going to be a decent driver. If you don't do well on this permit test, you're not given your permit. We want to make sure that you're okay. We think that your behavior will be okay on the road. The other is content or criterion. So for example, you've already taken your permit test. That's predicted your behavior. When you go and you actually take the road test, we are measuring that specific driving behavior. So we call that content or criterion validity. Standardized tests can be measured in a bell curve. That's the normal distribution of scores on a test. So this is your normal bell curve. This is the shape of it. We use this because we know that intelligence testing does fall in that normal bell curve. So this line right here down the middle, that's going to show you your measures of central tendency. That line is the mean and the mode. For IQ, we know that that is 100. We also know that this is the 50th percentile. With a normal bell curve, one standard deviation away here is 15 points. So one standard deviation away to the positive, your IQ score would be 115. One standard deviation away to the negative, your IQ score would be an 85. Two standard deviations away to the negative, your IQ would be a 70. Two standard deviations away from the positive, that's looking at a 130. These percentages are very important to know as well. Someone might ask, what percentage of the population falls within one standard deviation from the mean? So we know the mean is 100, and if I'm going one standard deviation away from the mean, that's 85, that's 115. But I asked what percentage of the population. So I have to take this 34, and I add it to this 34, and I know that 68% of the population fall within one standard deviation from the mean. Please watch this video. I will attach it to your Edmodo folder. What is the Flynn effect and why is it happening? The Flynn effect is saying that intelligence tests, they have actually been scoring, people have been getting higher and higher scores on intelligence tests over the last several years. And there's no real explanation for it. Some people might think that it has something to do with nutrition, education, technology, but there are a lot of reasons as to why this could be happening. There's no exact cause. We know that your intelligence is influenced by your genes, and we know that from studying twins. So if you look at this chart, identical twins reared together, we know that they are actually the closest related in intelligence scores as compared to unrelated individuals that are living in the same house. And here we see that this is true too from adoption studies. So kids are more like their birth parents. Here's children and their birth parents and how like they are in intelligence scores. Adopted children and their birth parents, how close they are in intelligence scores. And here are adoptive parents and their adoptive kids in intelligence scores. They're not very much alike. School is a factor, and we know that if we get kids in schools early and we try to educate them, that will help with their intelligence scores. We know that there's a reflection of education in your intelligence scores. It's not everything, but we're finding it to be a little bit helpful. So we do have Head Start programs. Those are programs that we use in for people who are of a lower socioeconomic status to go ahead and get those kids in school early to make sure that they are in an enriched environment that can really benefit from it. This is an example of how the environment can affect us. So if you have one packet of seeds, all the seeds are the same. You plant one in poor soil and one in fertile soil, you're going to have differences in growth. Just like people. If you put people in different environments, you will have differences in intellectual growth. We also see differences between white Americans and black Americans, as well as Hispanic Americans with their IQ scores. The average IQ for white Americans is 100, while black Americans it's 85, and Hispanic Americans fall in between. And a lot of that will have to do with environmental influences. We find that women and men do test differently. Girls are actually better spellers, they have bigger vocabularies, they're more sensitive to touch, taste, and color. Boys will outperform girls in math problem solving. Boys also outnumber girls in counts of underachievement. Is intelligence the same throughout your life? Will it change? This slide shows that there is a correlation. So your IQ when you're younger tends to be pretty stable. There's a positive relationship there. So by age 7, your intelligence is pretty much stabilized. There are two extremes of intelligence. You've got the low extreme and the high extreme. So that low extreme says that if you have an IQ of 70 or below, you would be considered intellectually disabled. And there are varying degrees of intellectual disability. If your IQ is 135 or higher, here we see the gifted. An IQ of 70 or lower, we see that more commonly in men than we do women, and a lot of that reasoning is because of Down syndrome, with that extra chromosome on that 21st chromosome. This is the varying degrees of intellectual disability. It's really not that important that you know the difference from mild, moderate, severe, or profound, as long as you know that 70 or below a person is considered intellectually disabled. With the high extreme, we do see those who are very gifted, students that are 12 years old and they're graduating from college. A lot of people think that they are not going to function well in society, but that is not true. So it would be difficult being 12 and being in a class with all adults. It would make you feel a little more introverted. You don't have any real connections with them. But those students do seem to thrive, and they have careers and they do very well. So let's look at the test itself for intelligence. We do find a lot of bias in the test. There's never going to be a perfect intelligence test, but we do see that there are race differences that are socially influenced. People are genetically disposed to these race differences. And then also, the test might predict less accurately for one group than another, and so that's also going to prove bias. In testing, we do see stereotype threat. So, for example, being a woman, you might know that men test higher on maybe the SAT than women do. And so when you go in and you take a test, you might be in a room with a bunch of guys and you might start thinking, oh my gosh, they're going to do so much better than me. I'm not going to do well. And when you start thinking that, you are self-confirming your thoughts. And so you start performing poorly because you are thinking negatively, and thus it becomes a self-fulfilling prophecy.